Hello everyone. In this video, we're going to continue on in section R.7, okay, and do some similar things that we did in the last video with rational expressions. So the skill that we worked on in the last video was simplifying those rational expressions, okay, but we also need to know how to add and subtract rational expressions. That's an important skill that we'll use throughout the course, okay, and that you'll use in subsequent math courses. And so this involves a little bit more than just simplifying the rational expressions. So examples of what I mean by adding and subtracting rational expressions. We saw on the left, I have 2x squared minus 4 over 2x plus 5, and then plus x plus 3 over 2x plus 5. Okay, so that's an example, and there's also a subtraction example on the right for your reference. Okay. So there are a couple of different situations that you'll find yourself in when you're adding and subtracting rational expressions. The one that you want and the one that you're hoping for is when the denominator of both rational expressions are the same. Okay? When the denominators are the same, like what we have in the left example above, okay, that's easy because then you just add the numerators. Okay, add like terms in the numerator, and the denominator stays the same. Okay, so if I look in the numerator, the like terms are negative 4 and 3, and so I can add those numbers together and get negative 1. And so the final answer would be 2x squared plus x minus 1 over 2x plus 5. Okay, so this is easy. So we'll just say 2x squared plus x minus 1 over 2x plus 5. I combined like terms in the top, okay, and then the bottom just stayed the same. That's the ideal situation, okay, or the easiest situation for us to work with. The others, or the other situation that you'll most likely find yourself in, right, is when the denominators are different, such as the right example. When that happens, we'll need to use something called the least common multiple method. Okay, least common multiple method. What we're going to have to do is make our denominators the same. Right? So if we don't have it, like we do in the left example, we have to make it happen, like we will have to in the right example. So what is the least common multiple method? I took this box here straight from the book, okay? And so the book says, step 1, factor the polynomial completely in the denominator. Find the least common multiple of the denominators, okay? And by doing that, the least common multiple is the product of each unique factor, with each of these factors raised to a power equal to the greatest number of times that the factor occurs in any denominator. Okay. Step 3, write each rational expression using the least common multiple as the common denominator, and then add or subtract. Now, that sounds really challenging. Okay. Who even knows what they're trying to say in step 2? It's not that bad, I promise. Okay, what we're going to do, or an easier 2-step process that I'm going to propose here, right, is if we have the denominators and they're not equal, what you'll likely see is that either the denominators have nothing in common, okay, and if they have nothing in common, then you just multiply the two together to get your least common multiple, right? If there's something in common, to find the least common multiple, you multiply everything together that doesn't have anything in common. Okay? So we'll see what that means in just a second. So here's the example that I want to work with. We're going to try to reduce the following rational expression. Okay? And when I mean reduce, add them together, okay, to get one expression. So I have x over x squared plus 3x plus 2 plus 2x minus 3 divided by x squared minus 1. Okay, so what we need to do, clearly the two denominators are not the same thing. So we need to work to get them to be the same thing. And we do that first by factoring the bottom of each rational expression. So for the first one here, we have x over, and then we want to factor that polynomial, okay, meaning we want two things here with x and x. What two numbers add to 3 and multiply to 2? Okay, there's pluses both places, so we know that these are going to be plus and plus. The two numbers are 2 and 1. Okay? So that's the first rational expression. The second rational expression now is 2x minus 3 on the top. We aren't really going to mess with the tops right now. It's all about factoring the bottoms. We have x squared minus 1. Okay, now these are special polynomials that you probably dealt with in your math classes before. Okay, x squared minus 1 will actually factor into two things. Okay, it does look different than the left polynomial in the denominator here, okay, because it's missing that x term. So if you want to think about it in another way, you can rewrite this bottom here as x squared plus 0x minus 1. Okay, so I just added in a 0x because 0 times anything is 0. Okay, so it's just sort of a placeholder. Now I need to think what two numbers, so I have x and x, I have a plus and a minus, so I know there's going to be 1 plus and 1 minus. Okay, what two numbers add to 0 and multiply to negative 1? Add to 0 and multiply to negative 1. The two numbers that do that are positive 1 and negative 1. Okay? See that? Positive 1 and negative 1. So x plus 1 times x minus 1 will get you this, and then the 0 goes away, which will get you that. That goes away. So hopefully that makes sense. Okay, so now I have my denominators factored. And so you have to think, is there anything in common to these? And yes, there is. And x plus 1, okay, is common to both. So what's missing on the left side is an x minus 1. And what's missing on the right side is an x plus 2. So, to fix this problem, what we're going to do is we're going to multiply this left-hand side on the top and the bottom by the quantity x minus 1. Okay? So, on the top and the bottom, we have x minus 1. I multiplied both the top and the bottom because I can't change the value of that rational expression. Okay, and so multiplying by this, which is really 1 in disguise, right? I have something divided by itself, which is really 1. I'm multiplying by 1, which doesn't change the value of the expression. So that's what I want to do to the left side. To the right side, what am I missing? I'm missing an x plus 2. So I multiply on the top and the bottom by x plus 2. Okay, so now we need to do some multiplication. So I'm going to leave the bottoms how they are. Okay, x minus 1 times x plus 2 times x plus 1. Okay, for both on the bottom. But in the top, I get, by the distributive rule, distributing x to both the x and the 1, I get x squared minus x over x minus 1 times x plus 2 times x plus 1. Okay, so that's just rewriting this. And then on the right, I'm multiplying two things here, so I use FOIL, okay? So I need to use FOIL, which is really just the distributive rule multiple times to get 2x squared first, outer plus 4x, inner minus 3x, last minus 6. Okay, so hopefully that made sense. I just did the FOIL operation on that. Over x minus 1, x plus 2, x plus 1. All multiplied together. Great. Now, I need to combine like terms on the top. So, on the top, I get 2x squared plus x squared is 3x squared. Okay. 4x minus 3x is plus 1x. Okay. Minus x is 0. Okay, so there's no x term. All of these cancel out. Then we're left with minus 6 over x minus 1, x plus 2, x plus 1. So you'll notice here that when I add them together, the denominator comes along and stays the same, and I combine like terms in the top. Great. Can I simplify this any further? The answer is yes, I can. I can pull a 3 out of the top. Okay, so I'm going to move down here, and I'm going to pull a 3 out to both. I get x squared minus 2. Okay, x squared minus 2 over x minus 1 x plus 2 x plus 1. Okay? Now, is there any way that we can simplify this further? X squared minus 2. Can I do something similar to x squared minus 1? Well, there's not. Okay? There's not anything that sticks out right away that does that. So, that's the final answer. Now, let's move on to a your turn. So, here's your turn. Here is your turn. Okay? What you're going to need to do is just what I did. Factor or simplify as much as possible the denominators. Find the least common multiple and make each of the denominators the same by multiplying by 1 in clever ways, okay? And then add everything together and see if anything simplifies from there. I'll see you next time.